Yeah, so I've been having the main difficulty is that I have not been able to. This concept should work, and I'm not sure what I'm calculating incorrectly. I've been really just. Happy snowy Pi Day. Today we have blizzard going on outside. Woo-hoo-hoo-hoo. Bruh! And I wanted to deliver kind of a cool video on, I guess it wouldn't be that cool, it'd be pretty nerdy, but we don't have school, and I thought to myself, I wanted to still appreciate Pi Day. Besides the eating kind of pie and stuffing my face, I can't go to the grocery store anyway. So I wanted to do a little bit of math. I'm hoping you guys can help me solve my problem. I know there are smarter humans out there than I. I'm hoping that you can help me solve this stupid problem. I've been stressing on it for
like 2 hours, just stuck.
Now I'm gonna explain the problem, and then please in the comments help me out. I got a triangle, and what I want to prove is that the ratio between the center to the side length is greater than 3.14. The ratio from the perimeter to this right here is greater than 3.14. And then I want to prove that the ratio of the perimeter versus the distance from the center to the corner, I want to prove that that is less than 3.14. So here's the issue I've been having is when I solve, so I've labeled my points A, B, C, and when I solve for A, I get this number right here, square root of 3 over 2. So if I have square root of 3 over 2 as A, then that, so 3, 1, 2, 3, divided by that number, it does effectively give me a number greater than 3.14. However, when I go to solve for C over there, right, so C is going to be this distance right here. Given that B right here is 1/2, I get a number that's greater than 3.14 rather than less than. I'm wondering if so the idea here should be that for every polygon that I draw, so I start with a triangle.
Go square, pentagon, hexagon, heptagon, octagon, nonagon, decagon, etc.
So the main idea here is this. As we have more sides, our polygon starts to look more like a circle. So as we start with the triangle, right, the ratio of the perimeter of the triangle versus A, or the point to side, should be greater than pi. The ratio of the perimeter versus C, the point in the center to the corner, should be less than pi. And then as we go on, it should continue that way, right? So it should be greater. It should be getting closer and closer to pi as we add more sides. So as you can see down here, right, the perimeter of the triangle over the triangle distance A is the greatest, and then the perimeter of the square over the square's length A, and then the perimeter of the pentagon over the pentagon length A. Eventually, till you get to the perimeter of infinite amounts of sides divided by the infinite side length A. Those should eventually be pi, right? Because infinite amounts of sides, that should be a circle. Yeah, so I've been having, the main difficulty is that I have not been able to, this concept should work, and I'm not sure what I'm calculating incorrectly. I've been really just stuck on the triangle because I've not been able to get this number over here on this side of pi. It's been over here. Every time I calculate this ratio right here, it ends up over here. So that's my problem. I would love it if a mathematician would help me fix my problem here. You know, I'm sure it's some stupid mistake or assumption that I'm making, or an equation that I'm incorrectly calculating. I think that's how we can appreciate pi, is look to see what the ratio is of a perimeter of any polygon, and how the more sides we add, the closer we get to pi. Thank you for watching. I don't really do too many technically mathematical videos. So if you like this, please subscribe if you want to see more. And if I could get a solid square root of 25 likes, that would be fantastic. Comment below what you liked about it, what you didn't like about it, what you want to see more of. Stay weird.